Unit 4, Triangle Congruence, question number 4. So I'm going to solve for the homework review as I always do. So the first question says, what is the coordinate of the point on the directed line segment from -5 to 8 to 5, 4 that is partitioned in segments into ratio 3 to 1. So in this case, guys, we have another graph. Okay. And we have our line segment, and a line segment is a line that has a starting and an ending point. -5, -8 will be approximately here. 5, 4 will be approximately here. And thus we have our line segment. Okay. So you can always use a formula, but again, I like to do it without a formula. So we need to partition it into 3 to 1. So that'll be 3 parts and 1 part. So that means a total of 4 parts. Okay. So for our x value, we need to remember where we started. So we started at -5, and then I went from -5 to +5. So that means I gained 10, and I'm multiplying it by 3 out of 4 ratio. Okay. So this cannot be completely divided, but we can simplify it. So both 10 and 4 divisible by 2. Divided by 2 is just 5. So this would be -5. 5 times 3 is 15 over 2. Then I'm going to use the butterfly method. Get a common denominator of a 2. Cross multiply and get -10. Cross multiply, I get 15. And then I am adding, so I would get 5 over 2 or 2.5. Okay. So now we're going to find the y value. So we have a starting y value of -8. I went from -8 to 4, so that means I gained 12, and I'm looking for 3 out of 4. Okay, so 12 and 4 divisible by 4 goes into it 3 times. The -8 I bring down. 3 times 3 is +9. -8 plus 9 is +1. So the y value would be 1. So 2.51 would be the point where it partitions it into 3 to 1. That would be right here. Okay. So let's try the next one. So the next one says, what's the measure of the angle of the triangle shown in the figure below? Solve for x. So in this case, we have a right triangle. Okay. And we're given some angles where this right angle represents 90 degrees, and we could use the rule that a sum of all angles in a triangle is equal to 180 degrees. Okay, so that means that 42 plus 90 plus 2x plus 6 is equal to 180 degrees. Combine like terms, that'll give you 132. Oh, I forgot this. So plus 6 is 138, plus 2x is equal to 180. Subtract 138, subtract 138. 2x will be equal to 180 minus 138, I believe is 42. Yep, 42. And divide by 2, divide by 2. So x is equal to 21. Okay. So again, that's what x would be equal to. That would be my answer. If I wanted to find what this angle was, I just plug in 21 here. So 2 times 21 plus 6 would be 42 plus 6, which is 48. And if I add all this together, 42 plus 48 is 90. 90 plus 90 is 180. Okay. So let's try the next one. So next one says, in the trapezoid below, the line ST is parallel to PQ. So ST is parallel to PQ. If PR is 20, so PR is 20, and SR is 16, so SR is 16, PQ is 30, PQ is 30, and RQ is 25. Then find the length of RT. So find the length of RT. So I need to find the length of this. So I'm going to call what I don't know x. Okay. So what we're going to do, guys, is that we're going to use our concept of let's use these two triangles right here. Okay, so we can use these two triangles to try to find what RT is, because these are parallel. We could also state no, we would have to actually use these triangles because that's the only ones that are parallel. Okay, so in this case, guys, I would use these two triangles right here because that's what actually has the parallel. Okay, so I rotate this top triangle, so this will still be that vertical angle right here, so this will still be R. This would be now S, this would be now T. Now we have this regular triangle right here. Share the angle R, this is P, Q. So this is 30, this is 25, this is 20. And then SR is 16, this is X. Okay? So I would say that PR, or line PT, divided by the line RS is equal to the line RQ divided by the line RP. Okay, so RT is X over RS is 16 and RQ is 25 over RP, which is 20. So I multiply by 16, multiply by 16, X is equal to 25 multiplied by 16 is 5 times 16 is 400. 400 divided by 20 is 20. So X is equal to 20. Okay, so let's try the next one. So the next one says the figure below is rotated 180 degrees clockwise and reflected over the y-axis. What's the coordinate of the image point T after the transformation? So the coordinate for T is 2, -9. Okay, so I need to do 180 degree counterclockwise. So counterclockwise means you're going opposite of the clock. So you'll be over here. So here the x values are positive, y value is negative. Here the x, if we go to here, this will be 90, 180, 270, so 180. The x value is negative, the y value is positive. So I'm just changing the signs. So T prime would now be -2, 9. Now we're gonna do a reflect over y. Okay, so reflect over y. Okay, so then T prime, T double prime would actually be, so reflect over the y means that when I got here, I'm reflecting it back to this side here. So that means the x value would change, the y value would stay the same. So the x value would change sign, the y value would stay the same. Okay, so again, guys, just like that. So then for the next question, we're trying to write the equation of a line, or of a circle, sorry. The general form is x minus h squared plus y minus k squared equal to r squared, where h, k represents the center, okay, and r represents the radius. Okay, the diameter is 2r. The area for circle is pi r squared. The circumference for a circle is 2 pi r, or 2 times the or pi times the diameter. Okay, so those are all things you need to know for a circle. Alright, so we can write the equation of a circle as x minus something squared plus y minus something squared equals something squared, where the center point looks like it's right here. So when the x is -3, when the y is 4, so I'll plug in -3, plug in +4, and the radius is, so from here to here would be from -3 to +3, so that's 6 units. Okay, so this will cover 1, 2, 3, 4, 5, 6 units. Okay, so negative and a negative makes out positive, so this will be x plus 3 squared plus y minus 4 squared equal 36. Okay, so again, guys, just like that. So r would be equal to 6. Okay, and again, if I wanted to find any of these things, I just plug in r. Alright. So let's dive into the actual lesson. Okay, so the actual lesson wants us to describe the sequence of two transformations that map the given figure onto itself or another congruent figure, where congruent means same. So it says determine a series of transformation that will map FQ or figure C onto figure D. So it says describe a series of transformations that will map it and then prove your answer. So I need to see what happens here. So from my perspective, I'm trying to go from C to D, so that means that I'm changing orientation, because if you look, it's facing a different direction than what it was before. So anytime I'm changing orientation, I need to consider some type of rotation. So in this case, it looks like it may be rotated 90 degrees. So I would say figure C rotated 90 degrees, okay, and that 90 degrees would be probably would actually be clockwise, because again a clock moves in this direction, so a clock moves in this direction, so that would be a 90 degree clockwise, okay. And then I would have to flip it to this side, okay, because if I rotate it, it's going to be a 90 degree clockwise, okay. So where that point is going to be up there, then I flip it to the other side. So then reflect over the y-axis, okay. So I need to prove this. So what I'm going to do is I'm going to use a point and I'm going to prove it using points, okay. So for me to prove it using points, I'm going to pick a coordinate on C. So on C, figure C, this coordinate is 2, 1, okay, and somehow it became this similar coordinate right here, negative 1, 2. So let's utilize the same concept here. So for our rotation, okay, or for our rotation 90 degrees, we swap them and then change the x value. So we swap them and change the x value. So if we have that point, so we have 2, 1, we would swap and then change the x, so the positive 2 will become a negative 2, the 1 stays the same. And then when I do the reflect over the y-axis, so if I'm reflecting over the y, that means the x value is going to change, the y value would stay the same, so it would be negative 1, negative 2, okay. Oh yeah, this is negative 2, I'm tripping, okay. So again guys, based on that reasoning, I would confirm, okay, and then I could pick another point. So this point right here is 8, 6. So if I have 8, 6, again I would swap and then change the x, so this would be 6 so this would be 6, negative 8, and then I would reflect. So now I would keep the y value, change the x value, so that would be negative 6 and then negative 8, okay. So and then this point looks similar to this point right here, which is indeed negative 6, negative 8, okay. So again, it has been proven. So let's try the next one. So the next one again says we're trying to describe the specific series of transformations that map figure W onto figure X. So again, when we're looking at this, guys, I will try to first evaluate what's the movement. So this looks like, so from my perspective, figure W looks like we first did a reflection, but if we reflected it from here, it would be somewhere over here. So actually I would have done a translation first, okay. So for this one, I would have translated, and if it looks, it's kind of close right here, so I would have maybe translated to the left. So translated left, okay. Let's see how many units would it be to do a translation to the left. So 1, 2, 3, 4, 5. So then I reflect. I'll probably translate left 5 units. Okay, you'll see why I said left 5 units. All right, and then reflect over the y-axis. Okay, so what I actually did in my head was actually reflect first. So if I reflected this, okay, I would change the x value, keep the y value, okay. Right here, 4, -2, if I reflected it, will become now -4, -2. That would be the same point right here. Then if I went to this here, it would be moved to the right. 1, 2, 3, 4, 5 units. So I actually instead reflected. So I did figure W reflected actually over y-axis, then translated left 5 units. Okay, so that's actually what I did. I did the reflection first, because again this is 4, -2, so then it will become -4, -2. Then I translated 1, 2, 3, 4, 5 units. Actually that will be to the right, because reflect. So no, actually it's to the right. It's to the right. It's actually to the right. So actually it would have been either one of these two. So it would have either been left 5 units then reflect, or reflect first then right 5 units. So actually either one of these two. Alright, and I can prove it, guys. I can prove it. So if I did the same point, so this point 4, this point 4, -2. If I did the left 5 units first, that means I changed the x value by subtracting 5. So that would be -1, -2. Then reflect over the y would have been change the x, change the x, keep the y the same. So that would have been 1, -2. So this would have been now 1, -2, which is this point right here. That's if I did it this way. But if I did it reflect over the y first, so that 4, -2. If I did reflect over the y, would have mean that I keep the x value, I change the x value, keep the y value the same. So that would be -4, -2, and then right 5 units would mean that I add 5 to this number, to the x value. So that would be a 1, -2. Okay. So again, guys, that's how you would go ahead and prove it for each of these different points. And if you try the same other points, it would work. Okay. Let's try the next one. So the next one, we see that we see some type of enlarging. It says describe the specific series of transformations that map x onto y. Prove your answer. So we're trying to make x become y. So we're making y bigger. So we're doing some type of dilation. Okay. So what I'll do is that I would dilate first, because when you dilate first you get a better accurate movement. Okay, so figure x was dilated by, so now we need to figure out how much dilated by. Well, because it's getting bigger, that means that I'm changing it by some type of whole number. So I'm multiplying it by a whole number, not a fraction. Okay, so this went from -3, so this y value went from 3 to 6. So from 3 to 6 means that I'm multiplying by 2. So I dilated by a factor. So I dilated by a scalar factor of 2. Okay, so that means that I'm multiplying all the y values from what it seems by 2. So yeah, because this was -3, 3, so this became 2, 6. This became 10, so that was a 1, 1. And that became 10, 1. Hope something is off right here. Something's a little off right here. Oh, I see what's off. I'm doing from X to Y, not Y to X. So I'm doing X to Y actually. Okay? So because I'm doing X to Y, I don't know why I'm doing Y to X. So X to Y means I shrunk it. So that means I'm actually dividing and making it smaller. So this went from 2, 6 to negative 3, 3. So 2, 6 to negative 3, 3. That would be, well, it's hard for us to quantify that, so we'd have to maybe just look at only the Y values. Yeah, we'd have to just look at the Y values. So this went from 6 to 3, so that's by half. That's by half. So that's actually by a half. Okay? So because this went from 8 to 4. This went from 12, right? No, this went from 6 to 3, and then this went from 2 to 1. Okay? So yes, by a half. So dilated by a half. Then what happened afterwards? So if we dilate it by a half, this will now become so by a half, so 2, 6 will now become 1, 3. That will become now 1, 3. That will be here. So then I would move to the left 1, 2, 3, 4 times. So then translate left 4 units. Okay, so I'm gonna prove that, guys, because I have a point right here, 2, 6. If I dilate it by a half, that will now become 1, 3. And then if I translate left 4 units, means that I'm subtracting 4 from my x value. That will be negative 3, positive 3, which is this point right here, negative 3, positive 3. If I did the same thing with this point right here, that's 10, 2. So 10, 2 by a half will be 5, 1. And then left 4 units will be 1, 1. Which is right here, 1, 1. Same right here, this was 10, 4. Okay, so 10, 4 by 1 half would be 5, 2. Then translate left 4 units would be 1, 2. So 5, 2, then 1, 2. Which is this, 1, 2. So again, guys, just like that. Okay, so let's do the last one, guys. Let's do the last one. So it says describe the specific series of transformation that map O to P. So we're trying to go from O to P. So we see a dilation right here, and then we also see some type of flipping of the orientation, so a reflection. So for this one, figure O, maybe we could dilate first. Okay, so dilated by scalar factor of, so again we're going from O to P, so that means I'm shrinking it. So I need to figure out how much I'm shrinking it by, so I'm going to look at the change in the Y values. Okay, well again we did a reflection here, so they should work still. Negative 6 now became, this is the same as this. No, I would have done the reflection first, then the dilation, because it'll become more accurate, because it's hard for me to determine what these are, because this is 2. So I think it's pretty hard for me to determine what this is, because it looks like some type of weird fraction, because at this coordinate right here, which is this coordinate right here, this was negative 3, negative 12, and then it became 2, 8, or are negative 2, 8. Okay, so negative 2, 8. So I would do it by I would do it like what the result is divided by what I started with. So I would do negative 2 over negative 3, and then 8 over negative 12. And that would simplify to be, so both these are divisible by 4, so this would be 2 over 3. Both of these are divisible by 4, so that's also 2 over 3. So I think it's changing by a scalar factor of 2 over 3. Yeah, 2 over 3. Because if I tried another point, so for example this point right here, that's negative 3, negative 6, negative 3, negative 6, and then it got to negative 2, 4, negative 2, 4. So yeah, I got the same negative 2 over negative 3, which is 2 over 3, and then 4 over negative 6, which is negative 2 over 3. So yeah, I got the same change in scalar factor amount. Okay, so 2 over 3 would be the scalar factor amount. Okay, so then I would do some type of, so then I flipped it to the other side, so I reflected, okay, over the x-axis. Okay, and I can prove it with using some of these coordinates. So like if I use this coordinate and this coordinate, so this starting coordinate was negative 9, negative 3, so that's negative 9, negative 3, divided by 2 over 3, which means I multiply by 2 divided by 3. So negative 9 times 2 is negative 18, negative 18 divided by 3 is negative 6. And then I would do the same thing here. Negative 3 times 2 is negative 6. Negative 6 divided by 3 is negative 2. And then I would reflect over the x-axis, so that means that my x value would stay the same, y value would change. So that would be negative 6, positive 2. And this point right here is negative 6, positive 2. Okay, so I just proved it.